Hello, everyone, and welcome to today's webinar, B-Cell Neoplasms, Insight into Diagnosis and Simplified Workflows. I am Cassie Saltman of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Beckman Coulter Life Sciences. To learn more, visit www.beckman.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Submit. Also, if you experience any technical issues, you can utilize this Q&A box and we will assist you directly. I'd like to now welcome our speakers for today's webinar, part of a three-part series. Jennifer McCallister, Medical Technologist, and Antoine Pacheco, Platform Manager of Clinical Flow Cytometry. Jennifer, you may now begin your portion of the presentation.
Good morning. My name is Jennifer McCallister. I'm a long-standing employee of Cabell-Huntington Hospital in Huntington, West Virginia. I titled my program today, There and Back Again, because not only do I love the Hobbits and the movies, but I also feel like our journey through flow cytometry through the years has been like a trek to more door from Mount Doom, getting to the top of that thing and throwing our rings in, and now that we've gotten clear lab, we are at the pinnacle of our flow cytometry journey, and everything is beautiful now. So this is my journey through flow cytometry. This is a standard disclaimer from Beckman Coulter stating that these opinions are all mine and don't reflect the policy of Beckman Coulter. So this is just a legal slide here. There's me, and that's a younger version of me. I'm looking a lot better than I do now, but I'm Jennifer McCallister. I'm a medical technologist. I've been here at Cabell-Huntington Hospital for almost 40 years. We're a 303-bed facility. We're located in southern West Virginia with a robust cancer center, an NICU, a pediatric hospital, a level 3 trauma center, as well as busy med-surg, orthopedic surgery, and all those other things that a local hospital would provide to you. We're affiliated with Marshall University Medical School, and that's what you're seeing there. That's our medical school and part of our university and our mascot, Marco. It's a great little school, and we have students of all disciplines. We have nursing school, we have med tech school, and we have a pharmacy school, and all of those types of things here. But being a smaller facility, I'm able to scout with my patients from their first diagnosis and follow them all the way through their recovery, hopefully. I get to go on all the bone marrow procedures and prepare my own slides, and I can be a real part of my patients' recovery. I know their names, and I can follow their outcomes. So that's the nice thing about being here in a small facility. I've worked here for 39 years, always in hematology and flow cytometry. And this is just a little picture of my lab, just because I love my lab. Started my career with an FC500. I don't know if any of you are old enough to remember the FC500, but it had 4 colors. And it was beautiful, and it worked well, and we had good success, and our patients had good outcomes from it, and we loved it. But my goodness, the endless pipetting. I don't know if any of you remember these things, but we had to pipette 9 different tubes on each patient just to get everything we needed for each diagnosis, and it was very time consuming, and it wore us all out, and you guys know what I'm talking about. So as soon as an LVS became available, we made the switch. And we love our LVS. We've had it for years and years and years. We never have trouble with it, but we were able then to, first we went to 6 color with the 2 lasers, and then upgraded to the 3rd laser, and we're able to do our 10 color flow, which we, pathologists just love. And there's our happy docs. When you got happy docs, you got happy techs, and he's very elated by these results we get from this clear lab. So, beginning to talk about what I should be talking about, it's the B-cell tube on clear lab. What we love about clear lab also is the no more pipetting, the no more cocktailing, no refrigeration, and the long, long shelf life of these tubes. They provide every antibody necessary for a proper diagnosis with a few add-on tubes for those special tubes we all know about. And it's just worked really well for our laboratory. One thing I do love, especially about the Kaluza and the clear lab tubes, is the quality control. The launch-specific downloadable QC is beautiful every time. I think probably an inspector just enjoys looking at this beautiful QC. It drops right into your Kaluza. This is just a representation of the control protocol, which I feel like the inspectors just love to look at. You can store them digitally. You can print them out and store them. It's versatile. The pathologist can remote in, look at everything you want him to see, and it's just been wonderful for us. We were all in to get in the clear lab, and then, of course, COVID came along, and my TSS, Frank Day, bless his heart, he came in and helped set up the demo, and we got everything in place. But basically, I had to set all this up by remote because of COVID. But we've really enjoyed our journey through Kaluza and through these clear lab tubes. And this is just a representation of the tube itself. It's all dried down reagent, beautiful. These are the antibodies included in the tube, which is everything you would need to diagnose any kind of B-cell neoplasm. So these are the ones I wanted to look at today. Of course, we have our typical chronic lymphocytic leukemia, and one we see the most: mantle cell lymphoma, follicular lymphoma, multiple myeloma, acute lymphocytic leukemia, plasma cell leukemia, which was very rare. We don't have that very often. And then we had one little hairy cell that I could pull up. I looked hard for a Burkitt's, but I just couldn't find it. This is just a classic CLL. It's to me, it's just beautiful. We have our DIM45 CD19 positive population there. I'll put a little arrow there so you can see it. I couldn't include all the graphs. I love all these graphs. They're beautiful. This patient was an older gentleman with an absolute lymphocytosis and numerous smudge cells on his slide. I really love the ungated plots on here. We noticed the DIM45 CD19 population colored in that beautiful bright orange. And we see that right here. Our next group of plots are all ungated, which I love to look at ungated plots. I think they're just beautiful here. We can see our monotypic kappa CD5 positive, CD200 positive, and very dim expression of CD20. It's a perfect, beautiful CLL. I could look at these plots all day long because they're just so nice. But this is clearly a case of CLL supported by the peripheral smear. This is just another of the gated plots where you can see very dim kappa, CD519 co-expression, CD19 positive. It's just a really, these are beautiful plots. And of course, you got your nice key here that breaks down everything in total number, gated, number, percentages, anything you need, you can have on this grid. Next, I wanted to put a mantle cell lymphoma up there because, as we know, it's still a CD5, CD19 co-expressed population of cells. But on this one, it's very interesting because, to me, you can diagnose it right from here because look at the very bright 20. 20 is very bright, where CLL, the 20 was very dim. We still have the CD5 co-expression and the monotypic lambda in this case. But there's our beautiful CD5, CD19 co-expression, lambda restricted. Then what you will see is in the differences of 200, usually the 200 works very well for diagnosing this as well with mantle cell and differentiating mantle cell from CLL. I just love these plots. I have to put them in here just because I think they're gorgeous. See this nice bright 20 here, co-expressing 19, lambda restricted, 200 is negative, 10 is negative, but look at this nice bright 20. That's what I wanted you to see, and the 19-5 co-expression. So it's clearly a good case of mantle cell lymphoma, supported by the rest of the things that need done with the specimens, the slides, and all the cytogenetics. This is a case of follicular lymphoma, This is a patient that she was younger, and it just shows our CD10, CD19 co-expression. We first diagnosed her on a fine needle aspiration, and as we see here with our CD10 being positive, lambda restriction, CD19, CD20 positive, had the classic characteristics of follicular lymphoma. And here again is the gated plots with our CD10 nicely positive, co-expressing with our CD19, lambda restriction. It's a very nice case we had here. This one I love. This was an older lady. She presented with multiple myeloma, pancytopenic lytic bone lesions. They did the bone marrow, and I did some backgating on the very bright CD38 expressing cells and colored them yellow. As you can see there, they're CD45 negative. They fall right where they should here, forward scatter versus side scatter, 45 negative. When you look at these plots, you can see the very bright 38, the falling in the 45 negative group, and the very bright CD48, 38. That's one thing that clues me into these all the time. It's the LDT add-on tube that we did after we noticed these cells, of course, confirmed the diagnosis with the bright CD138, the CD38 positive, there's CD56 very positive, CD117 also very positive, and cytoplasmic kappa. It was a beautiful case that we diagnosed. I think this one was just last week. We've had a lot of multiple myeloma lately. I don't know about you guys. This patient also had a beautiful representation of hematogens. I'd love to look at hematogens on these plots because here they are. They're in the dim gate, CD10 positive, beautiful trailing for the 20. I always was taught this is a way to diagnose what is a hematogen. See how the 20 trails like this. So she had a nice little crop of hematogens there. The next patient was an interesting patient. She was a younger lady in her 40s, came in with some malaise. We saw blasts on her smear. You know, you're always thinking at that age, you're thinking, oh my goodness, this must be a acute myeloid leukemia, but look what happened here. Amazing. It turned out to be a B-cell ALL. We don't see these on adults too often, once in a while. We were all surprised. On the ungated plot there, you can notice the dim gate colored purple. The cells are positive for CD34, CD10, CD19, CD38, 20, and 200. I think this is just gorgeous. I mean, here you see your dim 45 falling right in the dim gate there. 38 is positive. And if we look this way, here's our 34 co-expressing with our CD19. When I saw that, I was like, what? You know, that shouldn't be here on an adult, but here it is. We do have it once in a while, just not very often. I think these ungated plots are just gorgeous. CD19, CD10, CD34, CD38, all positive, like we would see in most children. This was a patient that was really interesting. We don't see this very often, but we were doing peripheral smear on this lady, and they all looked like plasma cells, which, you know, you don't see on peripheral smear very often. So we did a bone marrow on this lady, or this might have been a peripheral blood that I did. I can't remember which, but see the huge population of CD45, very dim, falling in here. These were all plasma cells, which was kind of different, so something you don't see very much. We did an LDT tube, you know, of course, to confirm the diagnosis. Look how beautiful these plots are. I just love them. So this lady, they are brightly 200. Then we had a hairy cell patient, which we don't see very often, and I couldn't pull up all I could find was my LDT tube on it, but we did take this up with our clear lab tube. See the red portion here, the lymphocytes that fall there in the myeloid or the monocyte gate 103 positive, CD19 positive, CD25 positive, 20 and 11C. So it was clearly supported by the LDT add-on tube, but we did pick it up with the clear lab tube as well. And this is just the gated plots of that same patient. I thought this was just beautiful. And, it's amazing that you could pick up, 0.94% of the lymphocyte gate, which was not much. It went ahead and picked all that up, even on our clear lab tubes, so we could diagnose this patient from such a small percentage of cells being positive. And one other thing I like to always talk about is the Clear Lab casebook. That is a wonderful compilation of cases. You have anything you want to look at is in this Clear Lab casebook. It's a great training tool for new techs, or when you're trying to learn this, the new system with the Clear Lab. If you have something you're not sure about, you can go to this casebook and find anything you need. So that's all I have on the beautiful B-cell tube. If you are using Clear Lab tubes in Kaluza, you need to be. It has made our life 10 times easier, so much more efficient, and we just love it. So thank you.
Greetings and a hearty welcome from our Customer Experience Center in Vienna. I'm Antoine Pacheco, the Global Platform Manager for Clinical Flow Cytometry. I'm currently in our state-of-the-art flow cytometry lab, which spans 233 square meters and is dedicated to live events, where customers can explore our workflow solutions in gene therapy, extracellular vesicles, and clinical applications. Depending on the lab size, assay menus, and objectives, we offer solutions to enhance efficiency for clinical flow cytometry, with application-specific technological advancements. Here, you can see our Atrios CL load and go flow cytometer designed for automated lymphocyte subsets and stem cell analysis. Next, we have the CellMec SPS instrument, which fully automates complex sample preparation procedures, including RBC lysing, cell staining, and washing. And now, let's introduce the star of today's session, the DXFlex flow cytometer. It's finally arriving in the United States, completing our global presence. One of the first things you'll notice is its compact design, which saves valuable lab space and ensures easy of use even in smaller labs. With a weight of 36 kilograms, it's easy relocatable. Let's take a closer look at the instrument. So the DXFlex operates without a large noisy compressor card. As you can see, there is nothing in the bottom, thanks to the built-in peristaltic pump that efficiently delivers cells into the system. No need to check a separate compressor or switch additional devices on or off. Just press a button and the system will start. The sheaths and waste tanks on the side are easily replaceable. The DXFlex allows you to add more columns to your panels without adding complexity. It simplifies high complexity testing. And I will demonstrate how it works now. Equipped with 3 lasers and up to 13 colors, it is CE marked for in vitro diagnostic use. In the US, the DXFlex flow cytometer is intended for 10-color immunophenotyping with the ClearLab 10C reagent system. Fluorescence channels FL11, 12, and 13, and all other uses are for research use only. Now let's have a look inside the system. So if I open here the cover, the lasers are in this box, the 3 lasers, the red, blue, and violet laser. And you see here for each laser, we have the optics here with the famous avalanche photodiode detectors. So each laser has its own detection module with small optical filters and avalanche photodiodes. You can see here on the right side of the system, this is the autoloader. It's the famous known carousel from Beckman Coulter. In the carousel, a 32 position tube, you have a triple identification with barcodes. So inside the system, you have a barcode reader, and you can read the carousel number, the position of the tube in the carousel, plus eventually the barcode on the tube. And as you can see here, we have here a single tube vortexing. So it's a real vortex who takes each single tube and vortex it individually. As you know, it's really important for critical applications to maintain the homogeneity of the sample. Today, we'll focus on the DXFlex startup, QC, and standardization process and measurement of samples stained with the B cell tube of the ClearLab 10C system. Okay, so let's start the software, the site expert for the DXFlex, and login. When you log in, the system software will start. And here you see the software menu. So the first thing, the software is really easy to use and very intuitive. The first point is to start up the cytometer. For that, you just need to click on the menu cytometer to press the system startup program, and the system will ask you to put in position 1 in the carousel a tube with at least 2 ml of deionized water. You just need to take your carousel, to put the tube in position 1 of your distilled water, deionized water, and just press start. It takes in total 10 minutes to start up the fluidic and to clean the system. The next point is to do the daily QC. For that, we have specific bits, who are the daily QC bits for the DXFlex. And these bits are used to verify the cytometer, but also to standardize the flow cytometer, the mean intensity fluorescence, the gains. So for that, again, very easy. You just go to the QC standardization menu. You click Start QC Standardization. The system opens a menu where you see already what you have done each day when you have run already the QC bits, and you just need to select the lot number you are using. So here we have already this lot, and the only thing you need now is to take the bits in a tube, to put again the bits in position 1 in a carousel, and just to press initialize, just to start up the fluidic. It takes 2 seconds, and you are ready to run your QC bits. You see, very easy. You just click start, and the system will start to make all the QC setup. So the system will measure the laser delay, will load the sample, and will calibrate the gains to standardize the cytometer. So you see here in fluorescence, remember that the system, the DXFlex has a high capacity of resolution because we have up to 7 decades, means more than 16 million channels, so high dynamic range, linked to the avalanche photodiode detectors. So as you can see here, the system starts to acquire the bits. Okay, look for all the parameters and start to measure the delay between the lasers. And when the lasers are checked and good, the system will start to calibrate the gains to ensure that you have every day the same intensity fluorescence. So these bits are used to calibrate also the mini intensity fluorescence for the ClearLab 10C reagents. So it takes approximately 1 minute to have this QC ready. You see, it's already down. The system has found the right settings and adjust the gains. And you see, it's in green, it's passed. So you see here all the statistics for the values the system found. So it's down, we are ready to acquire samples now. So let's see now the concept of the ClearLab 10C. First, we provide the tools for the compensation setup. So here we have, as you can see, the ClearLab compensation kit, okay, where you have different pouches of all the 10 single colors in dry reagents. So here it's the antibodies who are dried from Pixie. So I will show you here. Each bag has one set with the 10 single colors. And we have also the ClearLab capture bits for the catching of the antibodies. So you just put one drop of negative and positive bits on each of the tubes and you are ready to make the compensation. The next step is also, we are unique in the market right now because we provide stabilized control cells specifically dedicated for the ClearLab 10C. So it's normal and abnormal tubes. So I can show you, it's a 15 ml tube with stabilized whole blood. And in the abnormal, you have some cells who are expressing the CD34, 117, so all the immature markers. And we have the ClearLab 10C B tube. It's again 5 pouches of 5 tubes, so 25 tests. And on each bag, you have 5 tests. And it's where we focalize today on this kit, the B tube. So the idea is to run the two controls, the normal and abnormal, stained with the ClearLab B tube. Okay, so Beckman Coulter is providing the templates in the Beckman Coulter website for the ClearLab 10C tubes, so the BET and myeloids, and also the templates for the control cells. So the only thing you need is to create your panel experiment. So you go to File, you select the new panel experiment, you give a name. So I will call that the ClearLab 10C control B tube. Okay. And the idea is to run the normal and abnormal. So for that, you have here in the sample menu, new sample from panel. You create a new sample from panel. You go to the list, and here we have the B tube panel. So you select it, and we have one sample. The name will be the ClearLab control normal tube. Okay. And you see here, my tube will be the sample B tube with links to the matrix compensation and to the settings from the standardization process. I can add a new sample, again from the panel, so the same one again, the ClearLab B tube, and this one will be for the abnormal. So again, this is the ClearLab control abnormal. So here, I'm ready to put the tubes inside the carousel and to acquire. So I have prepared already the two controls, normal and abnormal, for the B tube. I will put them in a carousel number 1, in position 1 and position 2. It's in a carousel. And now in the menu, I just need to press the icon with the carousel. The system will ask me to add a carrier. It's already done. It's carousel number 1, perfect. Here, I will add samples in the carrier, and you see it's my panel. So I select all, and when I press in position 1, automatically the system brings the full panel in my work list. So I press OK. 2 tubes are already down. I can close it, and I just need to initialize. It takes 2 seconds, and I'm ready to press. So you have run, record, and auto record. Auto record means that the system will follow every single tube without asking you to press any icons. So after the end of the acquisition of the first, the system will go to the next samples. So here in the menu, in the software, you see the different graphics. And this is the templates we have downloaded from the Beckman Coulter website. So every single template is available in Beckman Coulter website. So these are the standard templates. I can put 10,000 events to display. And you see here a little bit the strategy of this template with a getting strategy on the doublets. After that, just getting on forward scatter, side scatter to avoid debris. You can move these regions without any issue. And then you have the CD45 versus structure, where you see the cartography of the cells. So where the cells are living in forward scatter, side scatter, and so lymphocytes, monocytes, and neutrophils. And this graphic here, it's mainly linked to the different normal populations. Remember, this is the normal control cells. So you see here the neutrophils, monocytes, lymphocytes, and eventually some dim expressions in CD45. And we apply certain colors on the system. So you see in red and orange, mainly the lymphocytes, in green, the monocytes, and in blue, the neutrophils. And after that, remember, it's stabilized control cells, so you cannot expect the same level of intensity than a normal patient or a patient, a real sample. But you see here, for example, the expression of CD19, the B cells, easily. So remember, on a normal patient, it will be much brighter. And you see here the expression of the kappa lambda on these B cells. So you see it's the normal one. And you have the side scatter versus all the other fluorescences. So you see here the expression of the CD10, especially on the neutrophils, the CD5 on the T cells. Eventually, if you have abnormal patients, you will see a CD5 positive for BCLL, for example. You have the CD200 on B cells. You have the CD34, if there is any immature cells, 38, and CD20 for this tube. Okay, plus all these double plots with all the fluorescences to see the compensation matrices. And you have also some reports. If I go at the end, you will see the report of the B tube. It's what we recommend to report the data to the LIS. So here the acquisition is around 5 minutes, but you can put a stop at any time. So here we have already acquired 50,000 events. And the system has stopped automatically and go to the next tube. So this one is interesting because this one is the abnormal sample, abnormal control cells. So you will see here during the acquisition, we'll focus probably a little bit more on the immature markers like the C34. And you see again the getting strategy on the doublets. After that, the forward scatter, side scatter to eliminate debris. After that, the CD45 structure. So let's get again, you see here, to better fit the populations in the right regions. Okay. And normally, if you check the markers like the CD34, you see here you have the abnormal cells. So I will probably put a rectangular here on it, put them, yeah, probably in green yellow. So you see here these abnormal cells. And it's around a certain percentage of the all white blood cells. So normally, if you look for the data sheet of this lot number from the control cells, you will see if you fit inside the range of the expected values. So this is the idea, and this will be the next step to reanalyze the data on Calusa. So you see here this abnormal sample where you see normal cells, but also abnormal cells in the tube. So here we have acquired already 24,000 events. Okay, and the system will stop automatically after a certain number of time or cells. If you want to stop, you can still stop it if you have enough cells and the acquisition is done. There we go. From Beckman Coulter website, you can download clear latency templates for QC control cells and data analysis and reports for Calusa-C. Calusa-C is available under a single license or network licenses and can be installed on offline computers dedicated to flow cytometry data analysis. It's part of the validated clear latency system workflow.
So, just one point. Remember Beckman Coulter to simplify the use of a ClearLab 10C is providing for the ClearLab control a data sheet where for each specific lot, for example, the lot here, you have all the expected range, the values and the expected range of values. So this is the first point. The next is based on Calusa. You can also download from Beckman Coulter website. You can download the dedicated templates for that. So there is a special menu with the OpenQC report activity where you can open the protocols you can download from Beckman Coulter. So these protocols are dedicated to the ClearLab control cells. For example, here we are on the ClearLab B cell tube control, the normal one. You open the template, and after that, you can drag here the file you have acquired directly from the DXFlex. So I will use this normal control cell. I'll drag it inside, and you have, based on the template, the protocol. So the only thing you need to do is to ensure that all gates are properly set up. So you see here, probably I need to readjust a little bit to take only the CD 200 positive cells. And the good thing is the first sheet is the gating strategy sheet. The next sheet is the report sheet. So this sheet is interesting because you have here all the expected range who are predefined by Beckman Coulter. You don't need to enter them manually. So it's interesting because, for example, here, if you take the CD19 cells, you take it out just to see what happens. You see all the flags here are appearing in red. So you see the CD19 positive and 20 positive cells, the B cells, are out of range because we expect around 13% and we are much higher. So let's put back here. Here we go. So this one is the expected range expecting. So you have also the old plot sheets just to have another view about the compensations. And finally, you have the leveraging graphs. So here are already inserted the expected range values plus the data. So I have actually only one data point in my QC report for this slot, but if I have some other data points, for example, here I have acquired a second normal tube, you just drag and drop it inside and you have a second plot. So on the plots, you see again the new data file here implemented in the full report. Again, you just need to check that all gates are properly set up. Just moving a little bit just to show you. Oh, I'm nearly down. Okay, so just check on the report if I'm inside the expected value. So there is no red flag. Perfect. So this one was the first part how to simplify the quality control samples. So you have already the templates. Now the next point is we can go back to the analysis activity. Here again, Beckman Coulter is providing for the patients, for the data analysis templates. So you can download from Beckman Coulter the templates for the patients. So here is the template dedicated for the B cell tube. Again, we have acquired, if you remember, on the DXFlex some control cells, and here I will use the data from a casebook. So we provide, again, in the Beckman Coulter website, this casebook file. So I will use first the peripheral blood for the B-tube. I will drag the data inside the template here. And you see all the data appearing. So the first sheet is dedicated for the gating strategy again. So just have to check that all cells are properly included inside the gate. So here you see the lymphocytes. You need to decrease a little bit the region to drag and move it on monocytes. And finally, I will include here the neutrophils, like that, and the lymph cells somewhere around it. Okay, and the rest looks nice. Let's see if there is no issue in including the other populations. Okay, this is the gating strategy where you see, for example, for the B cells, the kappa lambda expression and other expressions. So you have the comp sheet again here, where you can have an overview about all double color plots, all the combinations, just to check if there is no big issues in compensation. As you can see here, everything looks fine. And finally, you have also a report sheet with design, where you see on the first page the global populations, where you see the neutrophils, lymphocytes, monocytes, and the data. The next sheet is the B populations, and to check if there is any abnormal, I can say immature cells expressing the CD34. And after that, based on the B cells, you see lambda and other markers, etc., etc. So you have a lot of report sheets dedicated for each specific type of population, I would say. So this one was a normal case, and probably what we can do also is to replay the. We have multiple data inside the casebook, 15 different cases. So I will replay now the mature B cell lymphoma. So I will drag this sample here in the template. So be careful to ensure that the gates are properly set up on the system here. So here to include all the acquisition data. Look, the double discrimination. Here you see a large population. So probably we can include that inside lymphocytes area. Lymphocytes are a little bit higher and neutrophils somewhere like that. So let's just have an overview about this population. And as you can see, this population is probably expressing the CD19 and CD20. So CD20 positive, CD19 positive. So here, okay, you see again all the gating strategy based on that. And if you go to the report sheet, you see again, okay, the percentage of all the classical cells. So lymphocytes, we have around 93% of the white blood cells. And if you go to the next sheet, mainly they are CD19 positive. And you have all the expression of the kappa lambda, and we see the monoclonality kappa. So you can have an overview about all the other graphics based on the other populations. Okay, so again, as you can see, we simplify the treatment of the QC controls because on Calusa we have this QC report activity, and we have also templates for patients where we provide also these case books.
Thank you very much for attending this webinar. It's part of 3 sessions of our Leukemia and Lymphoma webinar series. We hope you enjoyed the program today and you are listening in again.
Thank you both for your time today. We would also like to thank LabRoots and our sponsor Beckman Coulter Life Sciences for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions submitted during the live or on-demand period will be addressed via the contact information you provided at the time of registration. This webinar is part of a 3-part series, and you can find details for the next parts under the resources component on your screen. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, see you at the next part.